In the early 2025 generative landscape, video creation relied on blind prompting. You typed a description and hoped the model interpreted your vision correctly. The entire process was governed by stochastic interpretation. Predecessor models often produced photorealistic frames that suffered from catastrophic breakdowns as the sequence progressed. Humans walked through solid architecture. Objects defied gravity. To extract a single usable second of footage, creators faced massive trial and error costs. SeaDance 2.0 addresses this by replacing the linguistic guessing game with precise directorial control. Historically, developers stitched together isolated models for video and audio in a cascaded workflow. ByteDance instead utilizes a unified framework to process diverse input signals in a single pass. This architectural shift moves the focus of generative video away from unpredictable visual experiments and toward the repeatability required for a commercial production engine. By generating audio and video within the same algorithmic step, SeaDance 2.0 removes the need for secondary third-party dubbing software. This structural matrix shows the scale of a single API request. The system can process up to 12 distinct multimedia reference files concurrently. 9 image slots are available to lock character identity and lighting, while 3 video files dictate the kinematic motion and camera trajectories. 3 dedicated audio slots then determine the rhythm, the specific voice acting, and the emotional tone of the scene. This is a reference to video, or R2V pipeline. It represents a departure from the text-to-video models that dominated the previous year. Successfully processing 12 different files without a system failure required a complete re-engineering of the foundational computational architecture. Standard unified funnels often struggle to process deeply contrasting data types simultaneously, as the mathematical requirements for a sound wave differ from those of a pixel array. SeaDance 2.0 uses a Quad-Modal Encoder, splitting the payload into 4 pre-trained pathways. Text extracts semantic logic. Images convert into 2D feature patches. Video extrudes into 3D spatiotemporal tokens for motion. Finally, audio becomes waveform tokens for pacing and lip syncing. Tokenizing these signals into a shared neural framework before the generation begins is the breakthrough that enables native audio-visual synchronization. Once tokenized, the data enters the dual-branch Diffusion Transformer, the core execution engine of the system. Expanding a model's parameters to handle this volume of data typically creates a massive computational bottleneck, making real-time inference nearly impossible. ByteDance uses a Sparse Mixture of Experts system. Instead of engaging the entire network, tokens route only to relevant neural experts. This increases parameter capacity while controlling compute costs, keeping the majority of the network inactive. This elastic training paradigm directly enables the different deployment variants: Pro for complex reasoning, Light for general production, and Mini for high-throughput tasks. The Mixture of Experts architecture allows the model to support high-concurrency enterprise requests while maintaining the processing power of a parameter-heavy research model. A major challenge in generative video is keeping a character's appearance consistent when the simulated camera angle changes. SeaDance 2.0 uses director memory and a reference cluster. These mechanisms bind specific identity traits to the global state, ensuring the character's face and clothing remain locked regardless of their movement. The system parses multi-shot instructions in a single prompt. Labeling a text prompt with Shot 1 and Shot 2 triggers seamless cinematic cuts, ensuring the transformer maintains narrative flow without halting the generation or losing character persistence. While these controls are effective for character consistency, the architecture has clearly defined limits. The model struggles with deep world physical intuition. When simulating complex fluid dynamics or light refracting through layered glass, the output suffers from structural artifacts. Additionally, there is a strict 15-second cap on continuous video generation. ByteDance chose to sacrifice deep world physics and extended take lengths to ensure native 2K resolution and rigid directorial control. The ability to perfectly replicate character bone structures and reference materials created an immediate existential vulnerability for the platform. Because the model can output unauthorized derivative works and celebrity deepfakes with high accuracy, it triggered a massive copyright crisis. Disney, Paramount, and Warner Bros. Issued cease and desist letters, while Netflix explicitly threatened ByteDance with immediate litigation over deepfakes of its intellectual property. Unions, including SAG-AFTRA, publicly denounced the model, citing concerns over pervasive intellectual property theft. This legal pushback forced ByteDance to indefinitely pause the official global API rollout for SeaDance 2.0. In a global market, scaling raw technical capability without building a robust compliance infrastructure inevitably results in a deployment failure. To mitigate liability, ByteDance deployed real-time IP filtering to monitor and block prompts targeting trademarked logos or celebrities. The infrastructure now embeds C2PA content credentials and invisible watermarking into every output file to establish a cryptographic record of the AI provenance. These restrictions have fragmented the market. While Eastern enterprise adoption is accelerating, Western creators often rely on third-party proxy platforms to bypass regional filters. This highlights the diverging philosophies of generative media: unbounded simulators designed for realism versus structured engines designed for production. SeaDance 2.0 demonstrates that the commercial value of generative AI is moving toward deterministic workflow automation. As the cost of execution drops, the economic value of media will shift entirely toward creative ideation.